in the same question of step number 4, let's see what it says. It says that what will be the weight of the ring immersed in figure 2 and to compare with figure 1. Okay, so basically now we have to find for this case. This case, what is the difference in this case? In this beaker now it's kerosene, it's not water, no water is there anymore. So in kerosene the density is different. In water the density was 1000, but in kerosene the density is 800 kg per meter cube. Okay, so now let's from previous solution, we know the volume of the ring. So how much was it? It was 5.18 into 10 to the power 7. 5.18 into 10 to the power minus 7 meter cube. Okay. Now, what is the mass of the ring? What is the mass of the ring when the kerosene is displaced? So let's write it mk rho k into v. So the density of kerosene is 800, and the volume is the volume of the ring, which is 5.18, into 10 to the power minus 7. So this is equal to, let's do the calculation. This is equal to how much? 4.14 into 10 to the power minus 4 into 10 to the power minus 4 kg. Okay. Now the amount of mass lost due to displaced water is equal to, so what was the initial mass of this object? 10 gram or 1 into 10 to the power minus 2, same thing, minus, this was the initial mass, and later the mass become, when it was dropped in kerosene, the mass of the ring became 4.144 into 10 to the power minus 4. 4.144 into 10 to the power minus 4. So this was the initial mass of the ring, and this was the mass of the ring when it was dropped into the kerosene. So what is the amount of change in mass? So the change in mass is equal to calculate this 9.5856 into 10 to the power minus 3 kg. Okay. Now, what is the weight of the ring in kerosene? So we know W is equal to mg. So we know m. This is m, amount of mass which is lost, and so now we can easily find out the weight in kerosene. Weight is equal to mg. So m is equal to 9.5856 into 10 to the power minus 3 into 9.8. So this is equal to 0.0939 Newton. This is weight. So this is Newton. So this is the amount of weight of a ray when it is immersed in kerosene. Okay. So do the comparison, do the difference between this and the previous one that we saw. So that is the comparison between these two solutions or these two beakers. Thank you.